My dear students, good morning. I am going to teach you the third chapter of 10th class, part first, pair of linear equation in two variable. So, the most general form of the pair of linear equation in two variable is a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. These are the two equations, two linear equation in two variable. There are two variable x and y. Here x and y. So these are the linear equation in two variables, and where a1, a2, a1, a2, b1, b2, c1, c2 are real numbers. The condition is that a1 square plus b1 square is not equal to 0, a2 square plus b2 square is not equal to 0. Now I want to define equation. You have read polynomials, and now I am today taking equation. What is the difference between polynomial and equation? In equation, there is a sign of equality. In polynomial, there is no sign of equality. This is a polynomial, ax square plus bx plus c. This is a polynomial. There is no sign of equality, and equation ax plus by plus c is equal to 0. This is the equation. Equation has a sign of equality, and in polynomial there is no sign of equality. This is the difference between polynomial and equation. Now, my dear student, if you want to solve the equation, first of all you have to write down the equation in standard form. This is the standard form. When equation is given 2x plus 3y is equal to 4, you have to make it in standard form. 2x plus 3y minus 4 is equal to 0. Now again 2x is equal to 3x minus plus 4. Now you have to write down this equation in standard form. 2x minus 3y plus 3y minus 4 is equal to 0. These are the standard form. So first of all, before solving the equation, you have to write down the equation in the standard form, and this is the standard form. First x, second y, then constant, then equality sign, and then 0. This is the standard form. So my dear students, today we are going to solve the two linear equation in two variables. That is, first of all I am writing two equation, and then the condition. By that condition you can check whether these equations can be solved or cannot be solved. Let a1 x1 plus b1 y1 b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. These are the two equations. We want to solve these equations, but first of all we have to check whether this equation can be solved or not. If not, then why should we try to solve? So therefore, first condition is this: when a1 upon a2 is not equal to B1 upon B2. A1 upon A2 is not equal to B upon B2. If you find this condition, A1 upon A2 is not equal to B1 upon B2, then the condition is consistent. The linear pair of equations in two variables are consistent. Understand here, these are the two linear pair of in two variables. If this condition, if you find this condition, the linear pair of equation is consistent. It means these two equations have solution. And you graphically you want to check these two equations, you will get these two lines will intersect at one point anywhere. This is the point, and coordinate of this point x and y will be the solution of these two equations. Second, A1 upon A2 is equal to B1 upon B2, not equal to C1 upon C2. This is the second condition. In this second condition, the equations are inconsistent. Inconsistent means these two equations have no solution. In these equations are, in this case, these equations are inconsistent. It means these two equations have no solution. When you plot these equations in the graph, you will get two lines are parallel. And when the lines are parallel, in this case, this is the case. When lines are parallel, when these lines do not intersect at any point, then you cannot get the solution, because there is no intersecting point, there is no solution. Third condition, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. This is the third condition. In this third condition, if all the three entries are equal, then these two equations are dependent. These two equations are dependent and consistent. Dependent and consistent. It means these two equations have solution, but infinite, many solution. And you plot these lines on the graph, you will get a single line of both the lines. First of all, plot the first line, you will get this line. Second, you plot, again a line will lie on the same line. Hence, all the points on this line will be the solution of that two equations. So these are the two equations. My dear students, before solving the equation, you have to check these conditions. If you get first condition, there is a solution, and it means lines are consistent. If second condition is there, then the solution is inconsistent. There is no solution. There is no need to try. And third condition, in all the entries are equal. It means there is a solution dependent on each other. Consistent and dependent, this is the condition. And you will get one line on the graph. There are many points on the graph, and all the points are the solution of these two lines. Infinite solution. Now, I am taking examples. Which equation can be solved or which equation cannot be solved. So, first example. Example first. In first example, I am writing first example. X minus 2y is equal to 0 and 3x minus plus 4y minus 20 is equal to 0. These are the two linear equation in two variable. This is the first equation and this is the second equation. And as I have told you, first of all you have to check these equations are in standard form or not. This equation is in standard form. Second equation is also in standard form. So now check these equation. A1 is equal to 1 here, A1. B1 is equal to minus 2. A2 is equal to 3. B2 is equal to 4. And C1 is equal to 0 because there is no constant in first equation, and C2 is equal to minus 20. Now A1 upon B1 and A2 upon B2. By putting the values A1 1 upon B1 minus 2, B A1 8 A1 upon A2, A1 upon A2, B1 upon B2. This is the condition. Sorry, A1 upon A2, A1 1 and B and A2. A2 is equal to 3 is equal to B1 is equal to minus 2 and B2 is equal to 4. A1 upon A2 is equal to B1 upon B2. B2 here 4. 1 by 3 minus 1 by 2 are not equal. So you should write these values very carefully. A1 B1, A2 B2. Condition is A1 upon A2, B1 upon B2. Now by putting the value of A1 A2 1 by 3 and B1 B2 minus 2 by 4 and these conditions, this condition A1 upon A2 is not equal to B1 upon B2. This is the first condition. Hence these two equations are consistent, have a unique solution. So we should try to solve these equation by graphical method or algebraic method. I will tell you later on these methods, and today I am only giving the knowledge of checking which equations can be solved or which equation cannot be solved. So this is the consistent. These equations have solution. Now we will find out the solution later on. Now second example. Now second, x minus 2y, x plus 2y minus 4 is equal to 0. 2x plus 4y minus 12 is equal to 0. This is the first equation. This is the second equation. And first equation is in standard form. Second equation is also in standard form. Now find out the values. A1 is equal to 1. A2 is equal to 2. B1 is equal to 2, B2 is equal to 4, and C1 is equal to minus 4, C2 is equal to minus 12. As I have told you in first example, write down these equations very carefully, these values very carefully, and write down the condition. A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Now, by putting the value 1 by 2, by putting the value 2 by 4, by putting the value C1, C2 minus 4 by minus 12, 1 by 2 is equal to 1 by 2 is equal to 1 by 3. These are equal, but this is not equal. Hence, this is the second condition. And in second condition, the lines are parallel. In second condition, as I have told you, this is the second condition in which the lines are parallel. There is no solution. It means inconsistent. Inconsistent. These equations are inconsistent. These equations are inconsistent. These equations have no solution. Therefore, there is no need to try to find out the solution of these equations because we have checked the condition. This was the second condition. So now again, I am taking one more example. Two x plus 3y. 2x plus 3y minus 9 is equal to 0. 4x plus 6y minus 18 is equal to 0. This is the first equation. This is the second equation. First check whether these two equations are in standard form or not. First is in standard form. Second is also in standard form. Now find out the value of a1 is equal to 2. a2 is equal to 4. b1 is equal to 3. b2 is equal to 6. c1 is equal to minus 9. c2 is equal to minus 18. Now by putting these values, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. By putting the values of a1, a2, 2 by 4 and b1, b2, 3 by 6 is equal to c1 by c2 minus 9 by 18. This is 1 by 2 by cancellation on numerator and denominator. This is also 1 by 2 is equal to minus 18, minus to minus, and this is also 1 by 2. This is the third condition in which all the entries are equal. So therefore, this is the third condition. An equation, solution of these equation is consistent, dependent and consistent. Dependent and consistent. This is the condition. Dependent and consistent. It means there is a solution of these equation, but not one infinite solution, because first line, second line lie on the first line. If you plot these two lines, you will get one single line, and all the points on this line will be the solution of these two equations. There are infinite many solutions of these two equations. Third condition applied. This was the third condition. So my dear students, if you find out the solution of two linear equation in two variable, first of all you have to check whether the solution is possible or not. If the solution is possible, then we should move further. If solution is not possible, leave that. So these are the three conditions. So I think you have understood, because it is a very simple way of learning. And next part I will teach you later on. In the last, my dear student, it is my request to you, please subscribe this channel. I shall be very thankful to you.